Good morning, everyone. This is Rob Sarmanian. How are you? We were going to get started momentarily. It is 9 o'clock. There are a couple of folks that are having a little bit of problems logging in. So I'm just going to give everybody a minute or two before we get started. So stay tuned. All right, I'm back. It looks like everybody is on board. Welcome again. This morning, we're going to have about a 2-hour presentation about Perk-Rite Drip Dispersal and a few logistics I'd like to just review with everyone before we get into the core of the material. We have quite a few people on the line this morning, and because of that, we are going to keep everyone muted so that potential background noise coming from your microphone could transmit to everybody else, and it could be difficult for me to communicate. So, but it doesn't mean that we can't answer questions. So if you look at your dashboard at the top right hand corner of your screen, there should be a little arrow that allow you to expand, and there's a little question tab. That question will send a question to me directly, and then I can either, I'll read it aloud, you'll remain anonymous, and then I'll answer the question. It may not necessarily be right at that moment because later on in the presentation, that topic could be covered and it'll naturally get answered. But typically, I like to use questions as a way to engage the discussion. For your participation today, we were approved for 2 CEUs. You'll get an email sometime probably beginning of next week. It won't be an actual certificate, but it'll just be something that you can keep a hold of and use for any type of licensure that you need. All right. So we are going to talk a little bit about these items today. So we'll go through what Perk-Rite Drip Dispersal is, specifically how the approval in Maine works. We'll walk you through a design and installation, techniques, and then kind of long-term sustainability. And then I think what will be most interesting to you, the audience, will be how has Perk-Rite been implemented in Maine, and what are some of the sites that could potentially be a good fit for Perk-Rite. So stating that, I'm going to kill my webcam. You don't need to see me, you need to see the screen. So let's get going. We are going to focus primarily on residential size applications. We will reference some large flow projects, both in concept and in actual systems that were built in Maine. Coming up in March, we're going to hold a special seminar for large system design and implementation in New England. So if you're an engineer that is interested in learning about how this could apply to you and some of your projects, look for an announcement sometime towards the end of February for a March webinar. So we're going to start with a little poll so I can get to know you all a little bit better. So the first question of the day is, what is your role in wastewater? Are you a system designer or a site evaluator? Are you a contractor installing septic systems? Are you a regulatory official? Are you a homeowner and or developer, or potentially like a system owner? Or are you in operation and maintenance? So I'll allow this to go for a few more seconds. We're just about at 100%. Okay, wonderful. So it looks like the overwhelming majority of you all are designers, and there are a few regulatory people and one homeowner or developer. Excellent. Next poll is, what is your experience with Perc-Rite Drip Dispersal? Is this webinar your first exposure to it? Do you know about the concept? You're here to learn more? You've been involved in projects before? Or I'm just here for the credit hours? So give it a few more seconds. Wow, everybody's very, very quick to respond. Excellent. So about half of you, this is your first experience or exposure to Perc-Rite. About a third of you have know about the concept, but you're here to learn more. And some of you have actually been involved with projects. Excellent. Thank you for that information. Okay, so Oakson, we are the New England distributor of a technology called Perc-Rite Drip Dispersal. We did not come up with this technology. It's actually a national product that's used throughout the United States and Canada. So it's something that isn't new to New England. We're actually came into the Perc-Rite distributorship in the early to mid 2000s, but it's been around for quite a lot longer. Oakson covers all 6 of the New England states. So this is our territory. And on our website, oakson.com, there is an interactive map. It's kind of like a Google imaging map, and you'll see these little dots strewn throughout the region. And what these represent are actual projects built. So if you wanted to look at specifically in Maine, you can see green dots and blue dots. Green dots represent a residential size system. Blue dots represent a larger or commercial system. And if you actually click on that dot, it'll zoom in and you can see site specific information. So for example, I clicked on the one in Phippsburg, which is Herman Island Campground. You can see on the left, when it was built, how many gallons per day, and then there'll be some picture examples of that particular site. So if you're interested in learning, where Perc-Rite is used in Maine, then you can certainly, peruse that map at your leisure. A little bit about the history of Perc-Rite Drip Dispersal. So the technology of using effluent to go through drip irrigation tubing was first implemented in the Middle Eastern countries in the desert in the 1970s. So municipalities would pipe treated effluent out to the desert and use irrigation tubing to grow crops. It was quite successful, and it's still implemented today. In the 1980s, an engineer from Michigan who settled in Virginia went out to Israel and learned about this concept and thought it would be, you know, fantastic to use in the States. So that engineer worked with some of the engineers in Israel and came up with the concept of Perc-Rite Drip Dispersal. They were issued their patent, I believe, in 1989, and the first systems were installed in the United States in 1990. They were first installed in Pennsylvania. In 2006, Massachusetts was the first state to approve Perk-Rite in New England. So Oakson was given an approval in January of 2006. In August of 2006, the first system was installed in New England. That was also in Massachusetts, clearly. Actually, or so we thought. So there's some little teaser there. I'm going to share a great story with you all later on. The Maine approval was issued in 2009. And in September of 2011, the first system was installed in Maine. And then as of 2015, the final state was approved in New England to give us, you know, a complete territory of systems and approvals. Let's talk about the concept. So Perk-Rite is equivalent to pressure distribution. So we do use a pump for all of our systems. So this is a pressure dosing system. You can use primary or treated effluent. So you can go right from a septic tank into a pump chamber, or have an aerobic treatment unit or whatever else, you know, is approved in your state. This can be used for new construction or upgrades or repairs. So any type of wastewater application can be used for Perk-Rite. And this is a little bit of a profile on how the system works. So we have, you know, a home generating wastewater going into your septic or treatment tank. It carries over by gravity into a pump chamber. From there, it pumps through a force main into a device called the hydraulic unit. And we'll go over the specifics of what that looks like and how it works later. From there, it pumps through a zone supply force main into a manifold. Sorry about that. I thought my phone was off. Through the manifold, it feeds through the drip dispersal tubing. And what's interesting here is that this isn't a perfect rectangular shaped field. It's cut off a little bit short because of a tree, and it actually works around a tree. And that'll be some of the advantages we'll talk about later on. After it goes through the tubing, it collects through a return manifold and is actually piped back to the hydraulic unit, which is a little bit different than most wastewater systems, right? Most wastewater systems are one way only, goes in the ground, and that's that. Here, we actually have a mechanism to bring that water back to the hydraulic unit. And then there is a line that works through gravity to travel back to the inlet of your primary tank. So that's in essence the flow pattern of a Perk-Rite drip dispersal system. This is a rendering of you know, any backyard. It looks a little congested. We have people walking around, but nonetheless, a single piece of drip tubing we call a run. So one run of drip dispersal tubing. When you have a series of runs connected from a lateral, is what we call it. So you have a single manifold connecting a piece. It goes through all its loops and ends in a return is a lateral. Multiple laterals connected together on a singular force main is called a single zone. So a zone of drip dispersal tubing. Most residential systems will be a one zone system. When you get into larger flow designs, we'll see the need for more zones. So we have our primary tank or our treatment into a pump chamber. There's the hydraulic unit. And then we have our supply line and manifold, return line and manifold, gravity return line. Then there's a control panel off the corner of the house. So there's going to be a mechanism to tell the system when to go on and off. This is not a demand-based system where a float will go up and then the pump will immediately trigger on. This is a time dose system that the floats tell the control panel, I have enough water. Now let's think about when is the best time to dispose of the effluent. There are air valves built onto the supply and return manifolds, and this will allow air to be pushed out of the lines when the tubing is being pressurized. It'll also allow air to come back into the system to help evacuate the tubing at the end of a pump cycle. And that, my friends, is a Perc-Rite drip dispersal system. This next picture shows you what we call the wetting front. So here is a series of runs or most of a zone laid out on a sand bed, and this is what it looks like when you run the system before you backfill it. It creates a wetting front. And what's very interesting about this picture is that it provides very uniform application throughout every orifice along the drip line. It's quite unique in the fact that every single orifice is providing the exact same application rate across the network of drip dispersal tubing. And how is that achieved? Inside the drip dispersal tubing is a device called a pressure compensating emitter. This device is on the back side or inside the tubing behind every orifice. There are orifices every 2 feet on center, typically on the drip tubing. And this pressure compensating emitter allows for that exact application rate to come out of the orifice, but it controls it over a very wide range of pressure. So on this operating curve, you see that when the pressure reaches about 7 pounds, then we have an application rate of about 0.61 gallons per hour. And then the curve, it remains flat all the way to 70 pounds. So that tells you that any piece of tubing that has pressure between 7 and 70 pounds will let out the exact same application rate out of that orifice. So why such a large range of pressure? This allows us to build drip dispersal zones on slopes or at higher elevation, significant higher elevation than where the pump station is. It could be significant distance away from the pump station, or it could be a combination. You may have a multiple zone system where one of the zones is 20 feet higher than the other. You could have a sloping site where the lower pieces of tubing could have 50 pounds of pressure. The upper pieces of tubing have 20 pounds of pressure, but it gives out the exact same application rate. And this is what it looks like. So we have the tubing sort of inverted. Inside the tubing may be, 7, pounds or 50 pounds, but once it reaches the orifice, the hole in the tubing, at atmospheric pressure, it just becomes a droplet. This were to be in the normal orientation and you were to hold your hand, underneath the hole, it'd be like a leaky faucet. So just drip about 1 every second. And that's how it works. So it doesn't spray, but if you did try to hold your thumb over the hole, there's enough pressure that it would come out every time. So it works, once it's buried, quite nicely. In order to achieve that operating pressure, there is a manifold, right? So we talked about that in the flow profile. And what we call for a more traditional layout where you have your supply lines and below grade, and then you feed up the laterals through the frost zone, we call a side feed manifold. So this picture shows the pipes just stubbed up out of the ground. We have some paint marks to where the tubing is going to lay out and loop, and then eventually the pipes will get cut down and transition into the drip line. So we call this a side feed manifold. For a sloping site, we have the force main go up to the top of the field, and then from there it feeds down and goes into the tubing. So this is a top feed manifold. So again, the pressure could be much less at the top of the slope, and it should be actually, than the bottom, but you're still going to get the exact same application rate. So we have sloping sites as top feed manifold, and flat sites would be called a side feed manifold. So I'm going to pause here just to say, questions are open throughout the entire presentation. So if you're thinking of something and you want to just put it out there, even if it, you may think we're going to, touch on the topic later on, just type it in, and it's a great way for me to sort of judge where to take some of the content of the presentation. So feel free to type in questions at any time. Okay, let's talk about the approval. The first Maine approval was issued in 2009, and then they did a quick little revision, and it came out in 2010. So this is in the actual page of the approval, and you read more of it on our website. And the approval gives us the ability to build new construction or repairs or upgrades, and we can deal with primary septic tank effluent or treated effluent. So it covers all the bases. So drip dispersal, Perc-Rite, is grandfathered into the state code. So as you recall, there were some revisions to the state code shortly after 2010. Perc-Rite retains the ability to discharge primary settled effluent through the irrigation tubing in the state of Maine. We are the only system that is approved for drip to be discharged in primary effluent in the state of Maine. So it's actually prohibited, in the code revision, but we maintain that grandfathered into the code. So there's no worries or questions about that. Very, very simple to design a system. So there's a loading chart in our design manual, and you will calculate how many linear feet per gallon you would need. So you have your design flow, you go to the chart, and that'll tell you how many linear feet of drip tubing would need to be installed in your particular project in order to meet the code. In the state of Maine, we see a lot of applications on islands and camps. So that is really the primary utilization right now for Perc-Rite systems. And currently we submitted some approval enhancements that are being reviewed by DHHS. The director retired recently, and there's some other staff that have been moved around. So we're working with them to sort of modify some of the approval. So hopefully that will be taken care of in 2021. And you'll see, and we'll actually make sure that we publish that, so all the site evaluators and designers in Maine will know what these changes may be. What is Oakson's approach? So we have a very comprehensive approach to how we're involved in projects. We work with designers right from the infancy of a project. Maybe it's just a concept. We'll help with designing the system. We work with the installers during the installation process, and then we'll make sure that the system is being operated properly over the life. So at this point, we're going to walk through a residential design. There is a handout attached to the presentation. So in your dashboard, you'll see a copy of the Maine design manual. Feel free to download that, here in the presentation, or you can go on our website and it's on there as well. If you prefer not to read an actual manual, you can watch a YouTube video on how to design a Perk-Rite system. So here's like a little snapshot of the opening of the video. So that's on our website as well. Also on our website, there are resources to help you with the whole process. So again, all the approvals and manuals, installation guides, all of the details you might need to pull together for your plan, more video tutorials, both for design and install, some questions, and then a design, calculator tool. We have a question. So I'm going to pause here for a second. Couple great questions so far. So one of the questions was, how deep is the system to prevent freezing? And another question was, what is the maximum slope allowed? So we're going to talk a little bit about depth and freezing later on, but just to answer quickly, we are approved to be as shallow as 6 inches below finished grade. So you would say, how could it possibly operate at 6 inches or even 12 inches for that matter? And the answer to that question is the tubing drains at the end of every pump cycle. On that operating curve, you notice 7 to 70 pounds. When it's below 7 pounds, the emitters just allow the effluent to drain out. So the pump shuts off, the air valves allow air to come back into the system, and it drops the pressure and pushes the effluent out of the line, so it is empty. And what is the maximum slope? We do not have a maximum slope written into our approval, but what we say is that, typically on very steep slopes, operating equipment becomes challenging. So we've worked on some very, very steep slopes, whereas a lot of handwork had to be done. So there is no maximum slope. You may think about, breakout concerns or whatnot. Because it's a very, very small controlled application rate, we don't see water, breaking out and running down the slope, even something that shallow. It's dealt with, it's very, very small doses that get spread throughout the network of tubing, and it works extremely well with slopes. And you'll see a lot of examples, later on. So thank you for those questions so far. So on our detail sheet on our website are these details laid out in AutoCAD. Now, this is a large sheet, a large format sheet. So in your HHE 200, you can actually pull some of these details and include them in smaller sheets. So that's what we see some of the Maine designers do, and I'll show you some examples. So what we see on Oakson's end is perhaps you'll draw a sketch and send it to us and say, hey, I have some concepts. Can you help me figure out how this may work on my potential project? Or sometimes we may see a more drafted version of a dwelling. We have a sidewalk we're working around. We have some trees. What can we do here? Can you help me, figure out a potential layout? Or, do you think this will work well here at my site? Or you can go right for it yourself. But here are some of the parameters that we should talk about for a system design. Again, here's that chart. We're going to determine the length of tubing required for your project. So if you're working with a 3-bedroom or a 2-bedroom, you have your gallons per day, you do your math, and now we need 400 feet of tubing. Okay, so how do I lay out that 400 feet? So clearly you're going to put it in the area on your site which you've done your soil analysis, and it's going to work well. The tubing can be placed as close as 1 foot on center. So if you have like a nice area that just for a bed that you don't have any objects you're working around, you can place it as close as 1 foot on center. Or on the contrary, you can go as wide as you needed. So if it's a wooded site and you have clusters of trees to work around, and you've calculated that you need 300 feet or 400 feet of drip tubing, you can place a run, 50 feet here. You might have to move 5 feet to avoid a cluster of trees, place another 50-foot run, and then work your way that way. So in the end, your soil absorption system may be quite larger in area than it would be otherwise, but if you think about it, you're not really disturbing the area. So it doesn't really matter how big it was if you have the room on your site. The good news is that you didn't really have to dig anything up, because as you'll see with some of our examples of installation methods, a lot of these systems in Maine are plowed into the existing grade or trenched around trees. So working around trees and other site features might or most definitely provide you a larger footprint, but because you're not using a lot of fill material, or if any at all, then it works out just great. When sizing your pump chamber, you're typically going to size it at 2 times the daily design flow. Because this is a time dosing system and not a demand dosing system, we need some operating volume, some EQ, the ability for the effluent to sit in the pump chamber and be dispersed over the course of 24 hours. So we'll talk a little bit about that more later on. And in our approval, we're allowed to be 6 inches below grade for seasonal systems, or 12 inches below grade for year-round systems. And that is actually one of the items that we asked the state to look at. We're at 6 inches burial depth for any systems in all our other states, and they work just fine. If you think about it, what's the difference between 6 or 12 inches when you're dealing with winter, right? It's still the same. So, and we have systems in northern Vermont that are year-round that are 6 inches below grade that work just fine. So that's one aspect that we didn't argue in 2009 for our approval, but now we have a track record in northern climates that we can share, and we feel as though that it'll just be 6 inches across the board moving forward. Okay, here is an HHE 200 of an actual project in Booth Bay. So the designer here filled out the forms, and you'll see that they checked off proprietary device, drip dispersal, and the sizing. They checked off linear feet. So they did their math, and then they came up with linear feet. Here are the soils, and here is a layout of the site. The designer showed the size of the bed he's going to choose, and then in relationship to the dwelling and the tanks, and then did a nice cross section of the burial depth and the slope. This is a cutout on the right-hand side of actual notes that came off of our details. So they chose to put notes on a single page and then some details on other pages. And here you can see those details. And we have a little arrow here for emphasis and this is what you would do in your plan. So you're going to specify and say, we have 8 lines, 75 feet long, 18-inch spacing, install with a plow to a depth of 10 inches. So the designer gave direction to the means of the method of installation, and then the spacing. And then here are some of the other pertinent Perk-Rite details, float settings in the tank, and some great depictions of how the manifold would be built. So very comprehensive depiction on the HHE 200 for this installation. So before I move on, any questions? So this is typically what a residential size design would look like using the forms in the state of Maine. Any questions? Okay, very good. So let me touch base a little bit here on a large flow design, just so you can see a little bit of the differences. So this is an actual project that is literally in midstream construction. This is Bonnie Eagle High School in the Standish Buxton area. And this is a wooded site for which they are running force mains into the woods from an existing treatment building. The school district has a treatment system, and they have a direct discharge that they were required to go subsurface. So they chose drip dispersal. So here are multiple zones laid out, in a wooded site. You can see all the different contours and the different force mains. So this would be an example of what a site plan would look like for a large flow system. For that, we will help design a custom zone layout. And you can see that, these may be rectangular up at the top for these two zones, but the bottom zones are a little bit irregularly shaped. So we worked with the design team to come up with these zone layouts. And then most importantly, we will provide the calculations as to the size of the pump, the size of the force mains, and we'll provide all the friction loss calculations and the run and rest times for the zones to the engineering team so they know how the system is going to work. I am paused here because I'm reading some more great questions. So let me pause here. A question was, how can the effluent migrate away from the tubing when the ground is frozen? Very good question. So the answer to that question is this. If you look at frozen soil under a microscope, the pores are it's actually more porous than unfrozen soil. So when you have one drop of warm wastewater coming out of the drip tubing at 48 degrees under pressure, that one drop can easily be accommodated into the frozen soil structure. So as the drops come out, it's actually thawing that soil structure around the emitter, around the orifice. Then perhaps when the pump shuts off, it could refreeze again, but because it unfroze itself around that orifice, it allows the draining can occur, and all the rest drains into that little pocket of unfrozen soil. On systems that work, I say regularly, right? So, 24/7 on a daily basis, oftentimes the soil never freezes underneath the drip system. And in some of the nice manicured lawns above the drip system, they will remain active for much longer into the season. So you may see the greener grass maintaining all the way post Thanksgiving, even into December, because you're supplying nutrient rich water to the root systems of the lawn, and it's keeping it active and not going into its dormancy. So that's how it works in the winter months. So take my word for it. I mean, we wouldn't have our approvals for 10+ years in all the New England states if it didn't work. But that's how it does work. And another question came out is, what is the cost compared to a traditional leach field system? I can't really answer that because I don't know what a traditional system would cost. You know, pipe, just regular pipe and stone, maybe that's not a, huge cost there, but there is a cost for excavation and whatnot. The Perk-Rite system does have a cost to it. We supply the pump, we supply the controls, the tubing, our installation support and whatnot. All that adds up to about $9,000. And that is going to be more than just buying the pipe and the stone for a more traditional system. But when you're dealing with an island and you're dealing with a camp and you can plow it into existing grade and don't have to, cut down trees or clear areas or even get a big piece of equipment over to the island, there is an advantage there. So if you can get a gravity system that doesn't really impact your yard, you're probably not going to choose a Perk-Rite system. But on a cost standpoint, when you factor in all those other things, Perk-Rite tends to be more cost effective for camps, residences where you want to keep trees, or those island applications. So, very, very good questions. Thank you. So back to this slide, we supply all of the calculations for these larger projects. We also show the equipment that's going to be built. And here's that actual piece of equipment that's inside the treatment building getting ready to be installed. And here is a drone picture of the treatment building and the access road leading down into the woods for where the drip system is going to be built in the spring. Currently, all the force mains are installed. The equipment is mounted in the treatment building, and then the drip zones are prepped. So all the trees were cleared that needed to be cleared, and sand beds were installed. The reason that we couldn't install them in existing grade was that there was groundwater mounding calculations that decided that the system needed to be above ground a little bit to deal with the high groundwater conditions. So it's only about a foot or so above the existing grade, but nonetheless the trees needed to be cleared out for just those bad areas. So from a regulatory standpoint, if you are reviewing a Perk-Rite design and it's your first time, you may have questions. No problem. Please reach out to us. We're happy to go through the design manual, our approval, and answer any questions you have. Sometimes we would attend meetings to help with projects. Typically, these are done on larger scale projects. But if you do require us to come to a meeting, perhaps it may need to be a Zoom, until the pandemic ends, but we're happy to assist. When we're finished with a project, we will issue a letter of certification stating that the system was designed properly and installed properly per the approval and the state code. And then what I feel is very important is that over the life of the system, Oakson remains on as a consultant. So if you're a homeowner that has questions later on, or perhaps you bought a home that has a Perk-Rite system and you want to learn more about it, we are going to be helpful all the way through the life of the system. Let's talk about some installation. So I think it's important that we define what Oakson's role is for an installation versus what the site contractor's role is. So Oakson is going to be part of the construction planning before it even begins. So we're going to send a list of materials to the site contractor for what they're going to need for the force mains. We don't supply the common pipe, so your 1-inch schedule 40, we're not going to buy it here and drive it up to you know, Bangor and install a system and then have to resell it. You know, it's common pipe will allow the contractors to secure that locally at their costs. We'll provide electrical schematics to help wire the system. We have video demonstrations of installations that are very in-depth for the contractor to watch so they can get a good idea of what to expect. We are actually going to supply an Oakson representative for the installation. So we do travel all the way north, and I say north because we're in Gloucester, Massachusetts, but we will travel as far as needed to help the contractor build the system. And our goal is to remove any guesswork from construction. So we're going to provide all the tools and support to the site contractor to be successful at their very first installation or their 20th for that matter. So what's the contractor's role? The contractor is going to supply and install the tanks. They're going to prepare the drip dispersal area, whether it be a sand bed or if it's a wooded installation, then maybe they'll flag the areas that we're looking to install the tubing. They'll provide that rigid PVC. They're going to work alongside Oakson during installation of the Perk-Rite components. They will secure an electrician for the wiring, whether they're going to utilize their own team or hire one or advise the homeowner to hire one. So that's on the contractor to make sure that the electrician is secured. And then it's on them for backfill and any compliance documents to have the system compliant at the end of the installation. So let's go through some different types of drip tubing installation. So on a sand bed. So this particular project is interesting for many reasons, despite it being just laid on a sand bed. You can see there's some slope. You can also see that it is not laid out in a rectangular manner. So that every piece of tubing almost is a different length. So Oakson and the contractor made sure that all of the jogs in the field were staked out. And then we went in and painted in reference lines to make sure that the tubing was laid with contour. Then at that point, it's just a simple process of cutting the tubing to the length needed and staking it down to the sand bed, connecting it to the manifold, and proceeding to test it and go to backfill. So that picture on the right, you can see the excavator, I think, taking its very first scoop to cover the drip dispersal tubing. So this is kind of like, if you look at our website, we have thousands of pictures available. A lot of them are on sand beds, just because that was the nature of the installation, but they tend to be somewhat redundant in that matter. To get into more interesting aspects of installation would be plowing into existing condition. So picture on the left, the site contractor is creating paint marks for the ditch witch to follow when we pull the tubing in. So this particular site has a little bit of curve and contour to it. So the site contractor took his laser level and walked along the contour and did a paint dot every 10 feet, then went back and actually striped the grass to create a nice line for the machine to follow along. And then the picture on the right is the irrigation contractor pulling the drip tubing in to the existing lawn following those paint marks. So this is something that you may not have seen before, but is very common for Perk-Rite drip dispersal installations. This method is using a ditch witch to pull tubing into a sand bed installation. This is the method that's going to be used for that Bonnie Eagle project that I referred to earlier. And you may ask, well, why would you go through the the trouble of using a machine to pull it into sand? Can't you just like stake it down like you showed in the first picture? And the answer is sure you can. But these beds for large systems tend to be 100+ feet long and even more wide. So a machine, an excavator, wouldn't be able to cast out and reach over the whole field. So we don't want the big equipment to kind of walk over the tubing itself, or it, place very shallow. So in this case, what you would do is the engineer would specify the tubing elevation and then an additional 6 inches of sand, for then the machine would come in and pull the tubing at a depth of 6 inches below that sand grade. Now the tubing's installed at the proper depth that was specified, and the topsoil can be spread with a track machine and driven over the sand bed because there's enough cover material. So this is why you would do it, for this type of instance. Now, here is an example of a trencher. So this is a hand trenching machine. It's like a little chain, right? A little chainsaw. You can drop into the ground and create a trench. The spoils move off to the side. This is the actual installation on that HHE 200 I showed you earlier in Booth Bay. The contractor specifically did the trencher here for a couple of reasons. One of which, there is a failed Presby system, I think 18 inches to 2 feet below this particular site. So the system was only in the ground for like 18 months and it failed. So there was a lot of good sand in between the failed Presby trenches. So the site evaluator got it approved to leave the system intact. We used a trencher to be more careful that we were able to drop the blade in. We wanted to get it into the good material in between the trenches. So they went and trenched all their line, trenched all the, did all the trenches, and then cut the tubing, put it in the trench, and then raked the material back over. So this application could also be used for, some wooded installations where there might be some roots that you want to go, or potentially some soil conditions that wouldn't be conducive to just the vibratory plow to go through. This last example is a little more common on island installations, but in this particular case, a homeowner really loved every aspect of their wooded site. You can see the water in the background, just a lovely, lovely site. They wanted to go through the expense of no sapling to be damaged or no rock to be removed. So a little bit extreme, but nonetheless, here's a Perk-Rite project. The site contractor blew all the leaf litter off to the back. You can kind of see that in the pictures. So this installation was done, I believe, I want to say, maybe mid to late October. So they blew all the leaf litter, hand trenched all of the areas where the tubing would go, around the saplings, around the mature trees, around the rocks, cut the tubing, put it in there, raked the material back, blew the leaves over, and we were done. A little bit extreme, but you see this on island applications, and we'll show you some more later on. So installing the manifold, this is not something that needs to be done by the contractor by themselves. So here's Oakson in the trench along with the contractor on the left, putting together the manifolds. And you can see on the right, this is the example of kind of a more traditional pressure distribution manifold. You have force mains below frost, and then it kind of goes through the frost zone. We provide a specification to help insulate those lines that go up to feed the drip tubing, and that spec, provides great insulation value for year-round operation. Now, at this point in the presentation, we have a little twist for you. We're going to show a couple of videos. The first video does not have any audio associated with it, so I will kind of narrate it over the course to kind of describe what's going on. The second video is one of the in-depth installation videos that we have on our website. That entire video is about 17 minutes long, and I'm not going to put you through the whole thing. I'm going to show you the first 2 minutes or so, just to give you an idea of not only what an install looks like, but also to the level of detail that we have in these online examples to help your installers or your regulators learn about what Perk-Rite is all about. So at this point, I'm going to start the video. Here's that vibratory plow going through that we showed the example before. You have those paint marks that they had in place, and they're pulling through very easily. Get to the end of the line, pull up the blade, cut the tubing, reattach it the other side, and do it again. Takes only a couple of hours to do the whole job. Here is an example of pulling the tubing in on a large system, and you can faintly see a string line along the outer edge of the track. That string line is attached to the stake, and it allows the operator to pull that piece of tubing in very straight. This is like 100+ feet. You can imagine, any movement, you would kind of, not get them in properly spaced. So you can see the spacing was quite nice there, and they did a great job. This video is taken from the Oakson drone. This is a system about 7,000 gallons per day. And what's interesting about it is that the entire disposal field for 7,000 gallons per day was installed in 5 hours. Each piece of tubing takes about 4 minutes. Now, this video is being shown back to you at like 3 times the speed, just because it'd be kind of boring just watching it truck along, but you can get the idea on how easy it is to install it, and you can get a lot done in a short amount of time. There's a spindle with the drip tubing over on the left. They attach it to the blade, drop it down to the depth, and just go, and it just uncoils off the spindle. The couple of other people mulling around, one of them is me, manning the drone, and the other ones are folks just moving those stakes and moving the string line just so that the operation goes as quickly as possible. So really, it's not a lot of labor here to get a lot done in a short amount of time. So the video slows down here at the end, so you can kind of just see the pace that it actually goes. And now that we zoomed in a little bit more, you can see the pigtails coming out of the ground, and those are going to connect to the manifolds later on. And that, my friends, is installation with a plow. Now I'm going to head over to the other video, which you will not hear me talk over, so hopefully you enjoy the next 2 minutes. Okay, I'm back. Hopefully you all got to see that and it didn't bore you to death. But if it does pique your interest, please, there's several of those on our website with different examples on manifolds and whatnot. I'll be doing the same type of video for the Bonnie Eagle project. So I do have some drone footage already that I have not broken down yet, but later on you'll see a wonderful video on that project. Okay, let's talk about sustainability. There have been active Perk-Rite systems since 1990. Those have been in like Pennsylvania area, but those systems are still active to this day. So if you ask me, what is the timeline on how long these systems are going to last, I can say 30 years, probably 35, probably more, because what the manufacturer did was they went back and dug out some of the original systems just to kind of get a look at the soil conditions below. And because the Perk-Rite tubing is installed very shallow in the soil horizon where the oxygen-rich bacteria live, there's no biomat. The things are just, they look as fresh as they were when they were installed in 1990. So the longevity of the soil absorption part of the system, the longevity is going to be, who knows? We're already at 30 years, and I think any of us would say if we can get 30 years out of our septic system, we all would sign up tomorrow. There are parts, pumps, valves and things that do have a lifespan. The pumps usually last 10 to 12 years, so that's not bad either. But these are all things that are very much easily swapped out if need be, and all the parts are readily available and stocked in the Northeast. The components are very durable. The time dosing promotes the great soil conditions that I talked about a little bit already. The return line that I described to you early in the presentation, let me talk to you about what that does for the system. This is a great part of the presentation to describe that. Now you may imagine, the question wasn't asked, but you may imagine that if you have primary settled effluent, which is, still has, a lot going on in there, in 1/2-inch pipe, couldn't slime grow in there? And the answer is, of course it could. And it should grow in there, right, under the conditions. But what that return line does is it gives us the ability to automatically flush all of the tubing on a routine basis to prevent any slime growth from occurring inside the pipe. So how does that work? In the hydraulic unit, and I'll show you more pictures of that later on, there's a valve, the return valve, that stays closed 90% of the time. So when the system turns on, it fills up all the tubing, it drips out, it fills up the return line, goes back, and there's a closed valve there. Everything's dripping, everything's fine. About once every 2 weeks, that return valve will automatically open up through the control panel and allow the wastewater to flush through the lines at scouring velocity. So any slime that's trying to grow in there will be whisked out of the tubing and then returned back to the primary tank through that gravity return line. So that is how the tubing can remain fresh and not clog over the course of 30 years, I guess. So the last thing, repairs, if very simple. If by accident, you drove a shovel through the tubing, you may create a little bit of a wet mess there the next time the pump comes on, but the tubing is shallow in the ground and there's a simple coupling. They just cut the bad piece of tubing out, splice in a new part, 10 minutes and you're done. When we first started selling this product in New England, we thought we were going to get calls all the time. We put in a bird feeder, or we were playing croquet in the front yard in a we put a wicket through the tubing. Not really the case, but there was one time that a fence company called and said, yeah, we were putting in a fence and we kind of got too close to the disposal field and we punctured a line, and no issues, 15-minute repair on a 25-cent coupling, and everything was back to normal. So operation and maintenance. So we have a requirement that the system gets looked at annually for preventative maintenance. So a trained operator, and we do have, operators in Maine, are going to come and kick the tires, so to say, on your system. So they're going to inspect all the valves, they're opening and closing correctly, look at the float inputs. They're going to help you figure out if your tanks need to be pumped or not at the time. They'll look at the pump, they'll just check everything out, they'll make sure everything is working properly. For larger systems, there'll be specialized O&M programs that Oakson will work with the design team, and they'll be implemented by operators, whether it be from the treatment plant or maybe the town may become certified and operate the system. But in general, we have a network of highly trained professional wastewater companies that can help you for your smaller systems. For the larger systems, we will train, again, town officials, wastewater operators, whoever you need to operate your system. Now's the time to look at what these actual components look like. So the pump and the floats. So there's your pump station to the right. The pump is a high head pump. It looks like a well pump, really. And what we do is we have a special way of mounting it in the tanks. We have on the left that little green device that acts as like a pump screen or a pump vault that it'll slide down. There'll be sump so that if solids did carry over into your pump station, they wouldn't get sucked into the intake of the pump. And then there'll be a quick disconnect coupling that you can easily reach down and pull the pump out to provide any service. So this is what the pump station looks like. And this is the hydraulic unit. So the top left picture is your typical residential hydraulic unit. It is mounted on or above a tank, usually, and it has 2 filters. It has a water meter, a flow meter, which is an unbelievable diagnostic tool. And I'm going to go over some of the things that flow meter does in a later slide. It has valves on there to allow the back flushing of the filters or the dosing of a zone or the return mechanism that we talked about. This sits in an irrigation box. You can see it kind of in the bottom left upside down, and that is accessed at finished grade. So as a green cover, can blend right nicely to your other septic covers and be accessible for the routine maintenance. The picture on the right is a larger hydraulic unit inside a treatment building, similar to the one we saw earlier on. Drip dispersal tubing we supply as well. Kind of seeing some pictures of it. There's an interesting contraption on the right, pulling in multiple lines at the same time on a very large project. Control panel, typically mounted on the outside of the dwelling, or it could be on a pedestal near if the field and or tanks are further away from the house. And on larger systems, there are touchscreen sophisticated panels that are integrated inside the treatment buildings. And those are our components. So what are some of the advantages of Perk-Rite? So now we're going to go into why would you choose to specify a Perk-Rite system and what applications have been widely used in Maine. Working with slopes. So if you have a sloping site and you don't want to have a retaining wall or have a big fill mound at the bottom of the slope, works very nicely. So you can see here them backfilling kind of by hand. The machine is kind of dumping it on there, and then they're spreading it out over the slope. You can follow the slope very nicely. You don't have to, again, lift it at the toe of the slope. So you tend to be as shallow as you can be on sloping sites. So when you have 6 inches or 12 inches of cover, it provides very good advantages. So this is a project not in Maine, but in Cape Cod. There was a failed system. It could be Maine for that matter, right? But it was down Cape Cod. So you have an existing failed system that was right here next to the walkway that the homeowner, if they used anything else, would have had a big, huge mound that would have interrupted their lovely view of the Atlantic. So by keeping it shallow in the ground, they were able to maintain the same height on backfill across from the walkway. Here's another example of a system that had to be close to the house, and because it had low profile, instead of walking out your front door and climbing over a 2-foot mound, the profile was kept at a very minimal grade to blend in nicely. This engineer went so far as to show their homeowner, what a regular system would look like if you chose to, use something else. This is a camp on the lake. They'd have to walk up over a mound to get to the sailboat, and the homeowner said, no way, build me a drip system. And this is what it looked like after it was built and with the grass reestablishing. So very nice result indeed. Flexible layout options. So here's a site plan where you have a well radius that they're trying to meet, some trees and some setbacks to the right, and it had to fan in a lot of slope. So you have a fanning situation, so not exactly something very traditional, but it worked out quite nicely with the Perk-Rite system. Here is a situation where in somebody's backyard, they had to, utilize a lot of area, and they didn't have a lot of room to work with. So they followed the property line offset and did basically a right angle shape. Here is a system just before the Maine border. This is in Portsmouth, New Hampshire. So we have a body of water, so the bay over here. You have a well radius, you have a property line setback, and you're close to the house. So they were able to fit a drip system in a unique shape, but sandwiched in amongst a lot of setbacks. But it came out quite nicely for the property owner. So Plowder trench installations, we talked about that a little bit. Let's look a little bit more. This is a camp up in Maine, Rome, Maine, and I'll talk about a little bit more later, but they pulled in all of the drip dispersal tubing in a field and allowed their campers to use it as, a soccer, or a frisbee or whatnot. And because of no mound and no disturbance, the campground was, remained relatively intact. This is an example of, pulling it in amongst a cluster of trees and then moving it over on another cluster of trees. So the homeowner loved the meadow look of their property and wanted to maintain that. Here's an example of that Hermit Island campground. So they're trenching the tubing in or pulling it in over up in the woods. So they didn't import fill. They kind of just dozed off a little bit of the bumps and grooves and then pulled it in at their desired depth. This is another island installation, and they pulled it in with a ditch witch, and there was a little bit of a disturbance, but you can see, that it'll grow back and maintain that same look, later on. So let's look at some more island installations. So off the coast of Booth Bay is Cabbage Island. So for all of these next examples, we literally put all of the equipment on a very small boat and went over and pretty much hand trenched it in. So this is Cabbage Island, and here is the finished system. So they actually just, this is a seasonal system, so they did not need to dig their force mains in below grade. We blow it out at the end of the season, but they were able just to hand trench everything in, set some tanks. You can see the hydraulic unit up to the side, and then they hand dug it in amongst the trees, and then planted some just wild mix just to grow back amongst the trees, hayed it up, and they were good to go. This is on East Pond. This is up near Waterville, and this is a freshwater pond example. So there's a small island here. It's so small that it's not even marked on the map, so it goes unnamed on the Google map. But there's a single residence on the island, and here we are pulling up to the dock off of the pontoon boat, and there is no electricity on this island. So what the owner did was he has solar panels to battery packs that run the drip system, and then his refrigerator, and then some lights. But it's a beautiful, beautiful property, and as exclusive as it gets. He's the only resident of the island. So they literally hand dug between the trees, laid the drip tubing, and it was a terrific outcome. This has been in the ground for about 9 years. Could have been the first. Well, Hermit Island is really a peninsula, so that was the first system installed. This might have been the first real island installation where I had to take a boat, but a great example. Mouse Island off of Southport has actual 2 systems. There's a very large cluster of homes that has a collection system, and then there's a caretaker. The caretaker system is year-round, and the other houses are seasonal. So one of the systems gets shut down, and the caretaker remains there year-round. So this is the caretaker's system, and there is the system for the 2 or 3 dwellings. So I want to talk about the flow meter a little bit here and preventing hydraulic failure. Drip dispersal Perk-Rite systems only discharge the design flow, and this is to protect hydraulic failure. So we've all seen tanks with leaky seams. We've all seen collection systems that take on rainwater, groundwater, and unfortunately we've all had leaky toilets. On a traditional gravity system, if you have a leaky toilet, your water is just going to pour into the system and eventually it's going to fail. There's just no way around it. Perk-Rite systems are designed so that the system will only come on and discharge your gallons per day. If you have a leaky toilet, you will get a high level alarm, and probably within the first few weeks of your system being operated. I'm going to get an angry phone call from an owner. I have a lovely homeowner in Bar Harbor who called me on Christmas Eve, 9 years ago, saying, "Rob, my alarm's going off." And unfortunately, she had a leaky toilet on a seldomly used bathroom, but because she had company over, she only was discharging her daily design flow, and it went into an alarm. But this was the system that was installed over the failed Presby system, and we figured out real fast maybe why those systems were failing really soon, is because she was hydraulically failing the systems. But because of this, we were able to help her determine why it was going to alarm, and since then it's been running great. So this flow meter will track the total flow discharged to the drip dispersal system, but it also will tell you the rate of flow that's going out to the system. So if we have 400 linear feet of tubing installed, because we know the exact application rate per emitter, we know that 400 linear feet equals 2 gallons per minute. We start the system up, we let it pressurize, we start our timer, and we calculate in the flow, and what do you know? We have 2 gallons per minute of flow. Everything is running great. 9 years later, we go back and do our routine visit. We pressurize the system. We check the rate of flow. 2 gallons a minute. 9 years later, everything's working great. The flow meter is a wonderful diagnostic tool. It also tells us we can figure out how many average gallons per day that the homeowner is using. So if it's once per year, we can just calculate it over the course of the year. Maybe sometimes the homeowner wants to know how many gallons they're using in a month. They can actually take the reading if they want to and just take a look at it and figure that out. Great diagnostic tool. And we're able to discharge off of timers because there are different floats in the tank that tell the control panel, at what rate of discharge that we need to do. So in the case of a leaky toilet or a leaky seam, the system is going to, the water is going to go up to the alarm because more influent is going in at the rate that is programmed to go out. So that's why you would get a high level alarm during a leaky toilet situation. But these are what the float system would look like inside the tank. Okay, we're getting near the end here, so I wanted to share with you some things that we feel as though we've learned over the years that are important from an environmental protection standpoint. So this is a slide that I stole from a very prolific person in wastewater in the Northeast, George Hoyfelder, and he did a study on the microbial activity in the different layers of soil. And what the result is that when you're in the oxygen-rich layers between 6 inches and 18 to 24 inches, there are millions of bacteria per gram of soil that are the ones that are responsible for kind of breaking down the contaminants that can be in the waste stream. So viruses, BOD, other aspects. So Perk-Rite is installed at these shallow levels. So that is why that it operates without much of a biomass, because it's actually treating the wastewater before it gets into the deeper soil structure, which has very little microbial activity because there's no oxygen present. So by installing Perk-Rite in the very upper soil horizons, providing excellent environmental protection, and there is science behind that. So that's why it works so well in those upper soils. We are involved in test studies right now that we're tracking nitrogen, phosphorus, fecal coliform, and other removal out of the Perk-Rite system with just primary effluent. So primary effluent through a hydraulic unit, through the drip dispersal tubing, in all different types of soils, sands, loamy sands, sandy loams, clays, and we're finding that the natural processes are removing most of the nitrogen, all of the phosphorus, and enough fecal coliform and BOD and TSS that Perk-Rite should be considered the equivalent of some of the treatment systems that are approved in the different states in New England. We're doing a virus study in conjunction with a lot of what the COVID protocols are doing, because a lot of people, they're starting to figure out, can COVID get into the waste stream? So we're doing a virus study with a lab over the course of 2021, and they're trying to see what that does, not just COVID per se, but all other viruses through drip dispersal and how that is working through the soil structure. So really high-tech stuff that we'll be happy to share with you all when the results are finalized later this year. So what are some of the trends of growth with Perk-Rite Drip Dispersal? A trend right now is municipal applications where towns, treatment plants, whatnot, are building Perk-Rite systems at existing facilities or new facilities and using common land in a town or in a subdivision or in a camp to dispose of the wastewater. And these common areas could be perhaps not the most beautiful areas or remote areas. They just want to pipe it away, or they could be in a common area used for use, you know, a playground or a soccer field or whatnot. So currently right now, the town of Bridgeton, Maine has a system approved for the discharge of 160,000 gallons per day. They chose to use a Perk-Rite Drip Dispersal system. So the system is approved. They started tree clearing and construction is commencing this spring. They are building a treatment facility along the edge of a main road, and they are running force mains up into the woods to dispose of 160 gallons per day. This is not the entire flow of the town, but it's a huge portion of the downtown area. There is going to be expansion available for the drip system, that if they wanted to add more flow, they could build future treatment trains and then be able to build more zones up in the woods and add on to the Perk-Rite system. So 160,000 gallons per day. So this is what the treatment building area is going to look like. You can kind of see the road. It's just 302, and then they're piping up into the woods into a series of many zones. This is a more sophisticated layout of what the zone profile looks like. And this is a layout of the treatment building and the Perk-Rite components and the current force mains leaving the building, and then the future if they decide to build more trains later on. So a very high profile, sophisticated project that we're looking forward to starting construction after the winter is over. So in closing, I'd like to talk to you about some really cool projects in a little more detail that we've worked on over the years. The first one, Wood Island. So Wood Island is located off of Biddeford, Maine, and it is a lovely and interesting place. So you can kind of see that it's very, very rocky all around the island, right? There's a small boat launch here on the left side of the picture. And all the way at the other end of the island is a lighthouse and a caretaker's house, all built in the early 1800s. This line across the island is a man-made boardwalk suspended off the ground with thorn brush, vegetation, hundreds of deer that swim across. It's about 4 feet wide, and it's the only way to get from here to there. The boardwalk is about 4 feet wide, and it's about a half a mile, well, probably about a third of a mile across. There is the lighthouse, and the lighthouse was under the jurisdiction of the Navy and then the Coast Guard, and they had an overboard discharge permit. But once the federal government didn't need the lighthouse anymore, the overboard discharge was revoked. So there was a group that came together called the Friends of Wood Island that wanted to renovate this house and turn it into a visitor center. so people could come over and see this historic landmark. So as you can imagine, they would need a bathroom or something, right? So with no overboard discharge available to them any longer, they had to go subsurface. So here is a site plan from I don't have the exact date on it, but it's in the 1800s that the designer of the new system, it was the last, I think, surveyed plan that they could go off of to design a system. So this is what they use to design the system. Here is the soil structure. Here is a layout of the drip tubing. And here we are taking the tubing and the pump over to that landing that I showed you earlier. Here is that boardwalk. So it's a little bit rickety. So hopefully they improved that a little bit. But there was one of the friends of Wood Island, the volunteers had a bike with a little trailer on the back of it that we put all of the Perk-Rite components over, and they drove it over and we walked behind. And there they are, hand trenching in the drip dispersal tubing. And I went up to the very top of the lighthouse to take some pictures and just to see how unbelievable this site really is. This is an above ground poured structure that they used for the overboard discharge for years, and they floated over a plastic tank to use as the pump chamber. So this became the settling tank, and this became the pump chamber. Because it's a seasonal system, they just laid the force mains on the ground, and they're going to cover it up with just some fill that they can just find over the island into the Perk-Rite system. This is an old cistern that was used, years ago. It's abandoned, but it's a nice relic. So the moral of this story is if you're boating off of Biddeford next summer and you need to use the restroom, please dock at Wood Island and be proud of the Perk-Rite Drip Dispersal system that you will be using. So the next example of a feature project, Pine Tree Camp in Rome, Maine. And what's interesting about this camp is it became infamous after the Perk-Rite system. I thought, by just the fact that Perk-Rite system was going to be built there, then everybody was going to know about it. But in fact, if you recall, probably about 8 years ago or so, there was the famous hermit that was, breaking into cabins and stuff and living off the land for 27 years. Well, he was shacking up mostly at the Pine Tree Camp and breaking into the different houses over the winter and stealing some rations and whatnot to live. So he was caught near the Perk-Rite system that was built in Pine Tree in, I think, 2012. So Pine Tree Camp, a lovely camp. I can't speak enough about the volunteers there. It's a camp for disabled kids, and what they do there is just wonderful. So here's North Pond Road that enters Pine Tree Camp Road, and this clearing over here is where the Perk-Rite system is installed. And it actually turned into an additional, they never used this as a just kind of like a leisurely area, but now they're able to use it for that. So you go down Pine Tree Camp Road, and here are all the facilities. What was interesting about this is that the original means of wastewater disposal was a lagoon. The lagoon was not on the radar of the state for many years. So the Pine Tree Association kind of inadvertently alerted the state that they had a lagoon, and then they had to get rid of it. So that's why they designed a Perk-Rite system to get rid of the lagoon. So it's 7,000 gallons a day, and the first order of business was they had to abandon and fill in lagoon through the Perk-Rite system. So although it was designed to handle up to 7,000 gallons per day, we hammered it early on to empty that lagoon so they could dry it out and turn it over. So here's the original application and approval from the state in 2011. Here is a sketch of that area. So let me go back a couple slides. You can kind of see this like area, and this mirrors it here. So we have 8 zones, all different layouts, all plowed into existing grade. Here is sort of the staked out disturbed areas after the plow kind of went through. And here is a picture a couple years later on how nicely the area was maintained. Now these rocks are set to make a sort of an access road. There are some electrical poles that go down there, so we want to make sure that any vehicles that can go through that don't drive over the shallow trenched in tubing. So this isn't actually like the road to drive down, but this is just so the zones don't get disturbed. So this area is now kind of used just as a, you can throw frisbees, play soccer or whatnot. It's a very nice area that now the camp uses for the kids. So the last example I want to share with you is not a Maine example, but it's in Rhode Island. So early in the presentation during the historical rollout of Perk-Rite, I mentioned that the first systems and approvals were in 2006. We were wrong. Oakson was wrong about that, and I'll tell you why. Charlestown, Rhode Island is located on the Long Island Sound, kind of close to the Connecticut border, but in very close proximity to the University of Rhode Island. The University of Rhode Island has a whole wastewater center where they have demonstration sites. And if you want to go into public health, there's a great center there that walks you through different types of technologies and stuff. Well, the professors at University of Rhode Island actually built a Perk-Rite system at a house, not occupied all the time, but it was kind of like a little rental cabin or whatnot on the water in Charlestown. And they used it as an example for, the testing center. They contacted American Manufacturing, which makes the Perk-Rite system, procured a system, put it in the ground just for the purpose of academics. I got a phone call during the pandemic in March from a homeowner saying, yeah, I bought this house and we're using it year round now because of COVID. And I got this alarm going off and I don't know what to do. And I happened to find these like plans as part of my closing package, and it has Perk-Rite Drip Dispersal on it. And I Googled it and I came up with your company name. Do you know anything about this? And I'm like, I don't know what you're talking about. I mean, we were involved with every Perk-Rite system in the Northeast. You're in the Northeast. I have no idea what you're talking about. So I said to the guy, I said, I don't want to leave you in the lurch. So send me everything you have. This is an old hand-drawn plan. He took pictures of it. There was some information on it. So I called the manufacturer. And if you can see by the date down here, where it says 1998 or 99 or something, there was one person left at the company, or 2 people left at the company. He said, Oh yeah, yeah, we remember that. Yeah, we sold a system to the university for no permits or anything. They were using it just for display. And we really didn't, we just helped them with the design and we said, here you go. And, you know, we're not approved in the state, but we know this is outside the state code. So, you know, good luck with that. So it literally was falling off the map. Nobody knew about it. And because the house wasn't utilized for residents, it kind of, then it got sold. And then all of a sudden it was being used. I drove down to Charlestown, Rhode Island, and took a look at all the components. And although they were, you know, much older and different generations from the stuff that we use today, very similar in layout. And this hydraulic unit is actually very, very similar to the ones that we use today. But what was wrong with the system is that the way that they backfilled it is not the way we backfill our systems today. We put 3/4 stone underneath the access box and around the perimeter of the box to prevent critters from burrowing in. So in this picture, you can see that there've been a lot of critters burrowing in, and they actually bit through some of the wiring and didn't allow and broke some of the valves and didn't allow the valves to open and close anymore. So they weren't opening and closing for a while, but just in the last month or so of the time of the alarm going off, they disabled, they had 3 zones, then they probably were down to 2, and then they were down to 1, and then they were down to 0. So for the course of 23 years, this system has been in the ground with some use, with no routine maintenance, but it managed to last all the way up to the point where the critters ate through the valves. So what I was able to do was procure the correct parts to put this house back in operation. And if you Google Oakson and you read our reviews, which we have a whole lot of 3 of them, this nice man down in Charlestown, Rhode Island, Bill Cords, wrote a very nice review of a system that has been running since 1998 and is still running to this day. So, my friends, we are at the end of the presentation here. And if there are any last questions, speak now or forever hold your peace, or reach out to me privately through email or phone call. I've thoroughly enjoyed presenting to you today. And then there's one last question that just came in that I'd like to look at. Would this be applicable for a residential island that is only open for 6 months of the year? Absolutely, 100% unequivocally yes. So there are many, many examples of island applications that are only utilized for a few months of the year. You know, Mouse Island is used 6 months of the year for a seasonal system, 12 months for a year-round system. Cabbage Island is only 6 months of the year, you know, during the seasonal use. Same thing with the freshwater island on East Pond. So yes, this can be used for seasonal islands. So on behalf of the team here at Oakson, I want to thank you for taking, you know, close to 2 hours of your morning here. Have a great weekend, and you'll be receiving an email with your credit hours sometime next week. And as I develop more of those videos for the main applications, they will be presented on our website. And lastly, if you will be attending the virtual MACE seminar, I think it's the 22nd or 23rd of this month, Oakson will be presenting an abridged version of this presentation. And if you do see it, I apologize if it's going to be a little bit redundant, but a lot of these examples that I feel are the best examples would be shared with the MACE community. But look forward to hopefully working with you in the future. So again, thank you for your time and have a lovely rest of your day and weekend.